day, sir. My name is HARISHWAR MOHAN from BMMH2313. My matrix card number is B0920100368. Here our group members name Addie, ZULFIKRI, HAZRIQ, HAKIM, Haris and Smail. So this is the presentation about fluid assignment pressure in pipe. About introduction, fertigation, the application of fertilizers with the irrigation water allows applying small amounts of fertilizer in each fertigation event that contributes to high flexibility in fertigation frequency. Two types of pipe configuration may be applicable for the watering process, namely straight line or closed loop. These two different configurations will give variation in terms of flow rate as well as the volume of water received by each plant. The situation later will affect the quality of plant itself. The continuation of introduction in physics and engineering, in particular fluid dynamics, the volumetric flow rate is the volume of fluid which passes per unit time. Usually it is represented by the symbol Q. Q equals to V times with A. V equals to flow velocity and A equals to cross-sectional vector area. As the continuation, the Bernoulli equation can be considered to be a statement of the conservation of energy principle appropriate for flowing fluid. The qualitative behavior that is usually labeled with the term Bernoulli effect is the lowering of fluid pressure in regions where the flow velocity is increased. This lowering of pressure in a constriction of a flow path may seem counterintuitive, but seems less so when you consider pressure to be energy density. In the high velocity flow through the constriction, kinetic energy must increase at the expense of pressure energy. So as the formula P1 plus rho V plus rho GH. So this is the main formula. So as our objective for this experiment, to perform an experimental and simulation flow exercise in hose pipe to analyze pressure variation in hose pipe over a specific pipe length with two different configuration. At the end of this assignment, students should provide, so we have provided inlet and outlet pressures, inlet velocity, density and viscosity of water, Reynolds number. That's all from me, sir. Thank you.
Assalamualaikum and hi, my name is HAZRIQ JULAILI, and today I'm going to tell about the experiment for our assignment. Okay, so first of all, we cut the water hose into the certain length so that we can connect to the pipe, and then we fully open the pipe valve so that we can measure the height of the water pressure for inlet pressure. Okay, right after that, during the same time also, we also measured the flow rate for the water inlet pressure. Right after that, we use the same length to construct a straight line configuration, and then we put the stopper in the end of the line so that the water will not distract on each nozzle outlet. Okay, so we install a 5 nozzle on the straight line, and then after that we also record the flow rate for the 100 ml of water. Right, and the second one is the closed loop. The closed loop configuration, we use the same length as the straight line and the same amount of nozzle as the straight line, but we use the T connector to connect the start and the end of the pipeline, so that the water will inlet in the two direction. Okay, we also record the flow rate for the closed loop and for the closed loop for 100 ml of water, so that we can compare between the straight line and the closed loop, which one is better. So how we determine the pressure? Alright, so we determine the pressure based on the Bernoulli equation. So what we got, the information here is the density of the water, then pressure of the atmosphere, and the diameter of hose, the height that we recorded just earlier, the time taken to fill 100 ml of water, the volume of the water, and then the area of the hose, the cross-sectional area. Okay, so we got the density of water 1000, and the pressure of the atmospheric pressure is 101.325 kilopascal. So the diameter hose that we use is 16 mm. The maximum height is 93 cm. The time taken to fill 100 ml is 1.75 seconds. The volume is 1 times 10 power of negative 4, and the area is pi r square. So our area is pi r, the diameter. Okay, so we got a 2.011 times 10 power of negative 4. So next is how we use the equation. So first of all, we use the flow rate, and the flow rate is a volume divided by time. So we got our flow rate is 5.587 times by 10 power of negative 5. So our velocity is flow rate v dot divided by area. So our area is 2.011 times with 10 power of negative 4, and our flow rate just earlier is 5.587 times with 10 power of negative 5. So we got 0.278 meter per second. So how we calculate the maximum pressure? So we use the Bernoulli equation to calculate the maximum pressure. So since we consider V1 is equal to V2, so we cancel the V1 and V2 for our equation. And then the Z1, we have no climb in Z1. Z1 we consider as the starting point. So P1 over rho of water times with gravity, and P2 that we consider as the atmospheric pressure times with rho of density and gravity, plus by the height that we record just earlier. So after we solve the equation, we got our pressure is 110.451 kilopascal. Alright, so for our two different configuration, we just use the diameter of hole of the nozzle as our information, the radius of nozzle, the area, cross-sectional area for the nozzle, our volume, our flow rate. Alright, so as you can see, the straight line, the straight line time 3.03, 5.69, 1.19, 1.85 and 1.77. Alright, so after that we calculate our flow rate, and this is what we get on each hole. And this after we gain the flow rate, we also can gain the velocity on each hole for the straight line. Same goes to the closed loop also. We have to calculate the flow rate, then after we gain the flow rate, we also gain the velocity of the configuration on each nozzle or each hole. So that's all from me. Thanks.
A very good day. Hi, my name is HARISHWAR. and I will presenting for the fluid assignment pressure in pipe for the BMMH2313, and my past are doing for the simulation from the ANSYS 2022. And for the further simulation, I proceed to our slide. As you can see from our slide, the first slide is about total pressure in closed loop. From the left side, you can see the total pressure based on the graph. It's starting from the below to the highest pressure that is 10752.9 Pascal, and the minimum pressure we get are 119.7238. Okay, and for the next slide, the total pressure in straight line. The total pressure in straight line, our team get around the max pressure is, as you can see here, is 10732.5. Meanwhile, the minimum pressure are 132.6476. In this, the left side of the graph, you can see, due to the straight line, the pressure are the same for each point. And we proceed to the velocity for the closed loop. As you can see, for the velocity of the closed loop, the maximum value that our team can get are 1.156065, and the minimum are negative 0.000149647. And on the left side, you can see the velocity on the graph suddenly peaked and went down, and then yes, we indicate the pressure are not stabilized for the closed loop. Then we proceed for the velocity of the straight line. Now, the velocity on the straight line, as you can see, the maximum on the velocity for the straight line are 1.0838.899 meter per second. For the minimum, negative 0.0351.90709. And for the graph, we can observe from the graph the velocity from the bottom, it rises to the highest at the point 1.0839, and then it maintain the velocity until it drop again at the 0.04. Okay, now to the next slide. There is density for two configuration, and for closed loop, the density of the water, as you can see, our team make a 4 point for the density calculation, and as you can observe on the graph, the density point at the for each point. Then for on the right side, you can observe the density on the closed loop are the maximum is 998.2004. For the minimum is 998.1996. Okay, for the density for the straight line, the maximum of the density is almost the same with the closed loop, 998.004, and where the minimum is 998.1996. And as we can observe from the graph, you can see the density of the water for the straight line is almost same, because the water consists flow in a straight line. If from the closed loop, the water will make a U-turn, but will affect the flow rate of the density of the water. And we proceed to the viscosity of the water. From this data, as you can see, the data of the molecular viscosity, the maximum are 0.00103, while the minimum are 0.001000299. This means the molecular velocity is very very smaller. Thus the water does not thick. And then we move to the straight line. The difference between straight line and closed loop of the molecular viscosity, because the water on the straight line is easily to flow because they have no how to say this, no traction between the water, and because at the public will proceed, the water are easily flowed in the straight line. Okay, we go to the other Reynolds numbers. Okay, for the Reynolds numbers on the data, it shows the maximum Reynolds numbers are 68.5066. Meanwhile, the minimum are 0.0102769. As you can see, the water on the graph are flow very slow on the closed loop because of the bend on the rubber hose. Alright. And for the Reynolds number of the straight line, we can observe the maximum 39.00522, and for the minimum of the Reynolds for the straight line are 7.0875. Exponent -10. And as you can observe from the graphic, the water flow slowly because there are no traction or the bend to easily affect the flow of the water. Okay, that's all for my parts of the simulation for the two configuration, the straight line and closed loop. And we proceed to others people to design their parts. That's it for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Addie ZULFIKRI bin MAZLAN. So I will proceed to the discussion. Based on the experiment result and simulation by using ANSYS 2022, the data from the experiment and the simulation are almost identical when the same pressure and velocity finding are used in both simulation and calculation show the same result. From the experiment, our finding about the different configuration, closed loop and straight line hose, when the pressure from the source are same for both configuration, but from our finding both configuration flow rate are different due to the closed loop are divided to two flow line for the experiment. Meanwhile, the straight line use one flow line that cause to a different flow rate in our calculation and simulation. Due to different configuration, the result for closed loop and straight line are shown to have effect on velocity because for each hole in the both configuration have a different velocity. Lastly, as the conclusion from this experiment, our group has been able to complete the task given by the assignment, that is to calculate the pressure, velocity and flow rate by manual calculate, and also by using analysis simulation tool ANSYS 2022 to do a simulation for the comparison between the manual calculation and simulation data to determine the both have the same outcome for the different configuration, straight line and closed loop. For the result, our team has gathered show that the result are same for both method. That's all from us. Thank you.